In this lab, the goal is to illustrate and analyze the concept of constant velocity motion. And this was done by recording an observation of my surroundings, in addition to using a computed model to show and analyze how an object that is moving in the same direction at the same speed exhibits constant velocity. In the case of my experiment, I was able to compare data from an observation using technology called Tracker and a model I produced in VPython, and was able to prove that my object indeed did show constant velocity, though there was a discrepancy in my data. This can be explained by simply the human error in which I could not keep my object moving in the same speed in the same direction for the duration of my video. We can use the knowledge that we have gained from Newton's second law and the momentum principle to help explain the concept of constant velocity. The momentum principle states that the change in momentum of a system is equal to the net force acting on the system by its surroundings multiplied by the duration of the interaction. The system is the object of interest, and the surroundings are everything else that it could interact with. Using the updated form of Newton's second law, we can say that if there is constant velocity, net force must be zero. This is true because if the velocity is constant, that means the final velocity and the initial must be equal, which means the second part of this equation must be zero. Now, since the object cannot have a mass of zero, and since the duration of time cannot be 0 seconds, the only part that can be zero is the net force. Now let's move on to Tracker, where I can show you my data. For my experiment, the system is a can of Coke, and the surroundings are everything that could interact with the can of Coke. A few of these surroundings include my hand, the table on which the can rolled, and gravity. It's hard to determine the total number of pushes and pulls acting on my object, but I was able to name those few. And we are able to say for certain that the net force is equal to zero. My video begins at frame 85 and ends about 1.67 seconds later. Now, the reason that my video begins at frame 85 is simply because the initial velocity of my can of Coke at the beginning of the video was zero until my hand interacted with the Coke. Here's the video. As you can see, the can of Coke is moving in the negative x direction, which means that my position over time graph located here will have a slope in the negative direction. If the axes were flipped, then that would mean that my graph of position over time would show a positive slope. And the axes, by the way, were labeled by finding the center of mass of my object and placing the x and y axis there. Next, I created a model of my data by altering code in VPython. The first part of the code that I altered was the ball's mass, which was 0.37 kilograms. Next, I edited the ball's position and the ball's initial velocity by using the data that I calculated by the tracker data. The next and probably most important part of the code that we altered is the while loop, which are the iterations that will show the motion in the direction that I had in my video. The first part is by changing the vector of net force to 0, 0, 0 to reflect zero net force. Next, I updated Newton's second law to reflect constant velocity motion. So the new version of Newton's second law in my code is ball.vel equals ball.vel plus fnet divided by ball.m times delta t. I also updated the position formula below. Using data from my CSV file, I was able to create a line graph comparing my model versus experiment position over time graph. As you can see, the model and the position data, the model and the experiment data, began overlaying exactly the same at the origin and a few points after. This is because the data that I inputted into Python came straight from the initial velocity and position data that I found in Tracker. However, over time, my experimental data begins to lag below. And this can be accredited to two possible reasons. One, that my object veered off of its path over time, or that there was a small interaction interacting with my can of Coke that slowed it down over time. Overall, this experiment does help to support the idea of constant velocity motion, and that an object moving in the same direction at the same speed will have a constant velocity, and that the sum of all the interactions will yield a net force of 0. Thank you!